In the last 20 years, the world has increased its energy use by over 40%, while the Middle East alone has had the highest global energy usage growth at 170%. Now, after lying underground for millions of years, more than half the Earth's fossil fuel reserves have been used up, and yet we have not found a viable replacement source of energy. And despite some brave steps taken in some parts of the world to develop alternative energy sources, fossil fuel still accounts for more than 80% of all energy generation because it remains the cheapest. A cheap, clean, and abundant alternative source of energy is needed, and scientists are looking again, hopefully, towards the source of most of the energy on Earth, the sun. In a single hour, the sun beams onto Earth enough energy to satisfy global energy needs for an entire year. Capturing this energy has so far proven inefficient and expensive, with storage being one of the main hurdles. Batteries are still not capable of storing enough energy and are also too expensive. But another form of life on our planet has been producing and storing clean solar energy for millions of years: plants. They use sunlight to turn carbon dioxide and water into carbohydrates, proteins, and oils. The process most of us know from school is called photosynthesis, but scientists have recently uncovered some of its secrets and are now trying to replicate the process artificially. Plants accomplish the task using chlorophyll, which captures sunlight, while a group of proteins and enzymes use that sunlight to break down water molecules into hydrogen, electrons, and oxygen. What scientists have discovered is that a chemical catalyst is important for the process, and in the case of plants, it is the manganese. A single atom is enough to trigger the process that splits water into hydrogen and oxygen. However, due to its unstable chemical properties, manganese has proved difficult to use in man-made experiments. And more recent advances have found cobalt oxide to be a more reliable alternative, with hydrogen being produced on one side of a cobalt oxide-coated silicon wafer and oxygen on the other side. Artificial photosynthesis is still in the early stages of experimentation, but the potential is promising and might enable us to one day produce hydrogen cheaply enough to use as an alternative fuel to power our electricity turbines and drive our cars. And that's a beautiful green dream shining bright in the stars of science galaxy.